There we go. Okay, so today it is October 6th, Octobre 6, miércoles. Our objective today really is linear functions. Okay, let's write down what that means. You know what it means, but let's write down what it means, okay? Linear means it's going to be a straight line. And I also taught you that linear also means an x to the 1 power, right? I taught you that as well. So if it's an x to the 1 power, it's linear. It's a straight, it's linear. And functions means that, you know, it's going to pass that vertical line test, or every x has exactly 1 y, right? So function notation, f of x. So for us, write this down. We're going to circle it. F, x, and y mean the same thing. F of x and y are going to mean the same thing for us, okay? Same thing. So whenever it's a function, we can say f of x, or we can say y. Sometimes we'll say y, sometimes we'll use f of x, okay? So just believe me, whenever you see f of x, it's the same thing as y, okay? Thumbs up? Now, let me see if I can describe. So you're driving to Spokane, average 60 miles per hour. Your distance is dependent on the time you drive. So d of t, this is a function. Distance with respect to time. Let's write that down. This is distance with respect to time. Okay? I could have written it as d equals 6dt. I could have written that. Okay? I don't need the d of t. I could have just wrote d equals 6dt. Okay? If I want to graph this line, because I want to graph it, and just trust me when I put the graph down, okay? I'll let you catch up. I do want to graph this. So when I graph this, my independent variable, I get in the car, what do I get to do? I get to drive, right? I get to decide when I want to stop driving. I get to determine the time driving, right? The distance is dependent on how long I drive, correct? So your independent variable always goes here. Did you guys learn that in science? Control variable always goes here. It's all right. Hopefully it looks easy. So what's going to have to go on this axis is going to be time. So I'm going to go time 1, 2, 3, 4, 5 in terms of hours. Okay. Let's do this. Okay. So my independent variable is time because I get to independently decide. So time, and that's in terms of hours, right? 1 hour, 2, 3, 4, 5. My dependent variable is distance. So if I drive for 1 hour, how far have I gone? If I drive for 1 hour, how far have I gone? If I drive for 2 hours, 3 hours, 4 hours, 5 hours, 300, right? So when I make my scales here, I at least got to get to 300. You guys agree with that? So I'm going to go probably 100, 200, 300. Of course, it's not going to be a perfect graph. It doesn't have to be perfect. But so when I do my scales, I got different scales. So this can be distance. 100, 200, 300 in terms of miles, right? Thumbs up so far? Seemed pretty easy? Okay. So let's do exactly what you said. I just heard the numbers. So if I haven't driven anywhere, how far have I gone? 0, right? 0 hours, 0 distance. I've got to get off the couch and get in my car, right? So I drive for 1 hour, and how far have I gone? 60, right? You agree with that? So, and I want you to write this.
So d of 1 is equal to 60 times 1, which is 60. Okay, d of 1 means the distance of 1 hour. That's all this means. Just weird symbolism. But all this means is plug the 1 in for time, so the distance for 1 mile is 60. Thumbs up on that? Does that make sense? So then I write d of 2, right? All right, d of 2. That's 60 times 2 hours, which is 120, right? So all I'm doing is saying the distance at 2 hours, 60 times 2, so I get about 120, okay? I'll guesstimate right about there. D of 3, what does D of 3 mean? What does D of 3 mean? What does D of 3 mean? Yeah, the distance for 3 hours, and that would be 60 times 3, which is 180 miles. You guys getting this? D of 4. Yep, which is distance after 4 hours, which is 240. Okay, right there. And then D of 5 is, what's D of 5 mean? What's D of 5 mean? It's 300 because the 300 because it's the distance after 5 hours, which is 300. Okay, everybody good? All right, now I'm going to connect the dots. And it seems so obvious why I'm going to connect the dots. We don't live in a time warp. It might be kind of cool to live in a time warp, but we don't just close our eyes, boom, instantaneously there, boom, we're driving, right? So we're driving like half an hour, 23 minutes, and we're driving, right? We're driving, so we're going to connect the dots, okay? We're driving. 5 hours, and then all of a sudden I say, "Oh, you guys, I gotta go to the bathroom. Please stop. You're killing me." Is it a straight line? Yeah, it's a straight line. So it's a linear function, right? So this is definitely a linear function. So think about this. It has to be a function. Because if I drive for 2 hours, can I be in 2 different places? Say it again, if I drive for 2 hours, can I be in 2 different places? Heck no. It's got to be a function, right? 2 hours, one place, right? Okay, I like that. I like that. I don't know how many people have done that, but you go to certain places, you can stand on one side of a state and the other side of a state, or one side of a country, the other side of a country. Yeah, it's kind of cool. I remember once when I was in England, I stood on one side of the Eastern Hemisphere and on the other side of the Western Hemisphere of the world. That was kind of cool. Anyway, moving on. So what's the domain? Tell me, what's the domain? Yes.
1, 2, 3, 4, 5.
Yes, and let's do this because all the numbers in between. Grace, I'm going to say, good answer, Grace. I'm going to go. So I'm going to use set notation because everything between 0 and 5, right? Because we also have 1.5, we have like 2.3 hours, or whatever, right? Good answer. What's the range? What's the range? What's the range?
60.
So we're going to go a distance of 0 to, what's our longest distance? 300. So 0 is less than or equal to d, which is less than or equal to 300, okay? Thumbs up. And since it is a function, instead of writing d equals, we write d of t. Again, it is a function, so instead of writing d equals, we write d of t. Awesome, okay? Now, example 2. F of x equals 2x minus 3. F of 0 means what? F of 0 means what?
What?
So we're going to plug 0 in. Plug 0 into what? Sure. So we're going to do this. We're going to go, okay, f of 0 is equal to 2 times 0 minus 3. So the 0 just goes in to the x, okay? And of course that's going to give me negative 3, right? F of 1. What does f of 1 mean? What do we do with the 1?
2 times 1.
There you go. Plug it in for the x. Totally right, Bailey. We're going to go 2 times 1 minus 3, which is negative 1. You guys okay with that? F of 2. What do we do? F of 2, what does that mean? Yeah. f of 2 is going to be 2 times 2 minus 3, which is 1. And then f of 3, what does that mean? Which is going to be 6 minus 3, which is 3. Okay, now we can graph this. These are technically points. These are points. They are 0, negative 3. It is 1, negative 1. It is 2, 1. And it is 3, 3. Okay, these are points. I plug in 0 and I get negative 3. That's what you said, Bailey, the y's, right? That's what you said. So these are points. And I can graph them. 0, negative 3, 1, negative 1, 2, 1, 3, 3. Now, I could plug in other points, right? I just chose those. So I could choose 1/2. I could choose 3/4. I could choose a lot. So I'm going to connect the dots. Because I could choose any number. And those are the numbers I liked. Okay. Now, is this a linear function? Is this a linear function?
Yes.
Yeah, it's straight, and it's definitely a function. So this is a linear function. And that's why I used f of x. Do you see that instead of y? Because it is a function. It is a function. Now you can use y. Some kids just don't like the f of x. It's kind of the same thing as y equals 2x minus 3, because Bailey said the f of x means the y, doesn't it? Okay, good job. Thumbs up. How am I doing? Okay, turn the page. So, in this one, here's we got a graph. It says find f of 2. So on a graph, find f of 2. Find f of 2. Okay. 2 would be some x value. Watch my finger. Are we watching? 2 could be some x value. What's the answer?
9.
Nice. It's 9. Is that easy? See how easy that is? Do it again. 2 is the x value. There's my x value 2. What's its answer?
9.
Isn't that easy? Isn't that easy? Do you see I did that? Because it is the y value. That's what you said, right? So let's write down what I did. Okay, I'm going to write this down. So f of 2. So we're going to find x equals 2. Then what is the y value? So if I go to 2 as my x, its corresponding y value is right up there at a height of 9. So f of 2 equals 9. Thumbs up on that one? Now, if it says find x, when f of x equals 1, now remember, f of x is y, correct? So in this one, we're going to find y equals 1. And then what is the x? Okay, so you guys see it? So what's the answer? Anybody know the answer to this one?
7.
Let's check it out, okay? Here is my height of 1. What's the x value? So it's asking the opposite, isn't it? Okay? So my x is equal to negative 2, okay? So, back to f of x is y, right? So if the y is 1, here's the y is 1, what's the x? Negative 2. Yes?
How did you find 9 again?
Okay, so if x is 2, what's the y? So if I go and I find 2 for the x, so here's my 2, right? Here's my x is 2. And I just use, let's see, I'm going to go up the graph, I find where it hits the graph. Elsa. Where it hits the graph, what's the height? What's the height at that point? 9. Can you see that? Okay. Okay, 4. H of x. So f of x, h of x, sometimes we give them different names because we've got too many functions going on, so we've got to name them different things, okay? Okay, find the value of x for which h of x equals negative 7. Okay, well, okay. H of x, now don't make this hard. h of x equals negative 7. So I'm going to put negative 7 right there. So I'm going to write negative 7 right there. So I'm going to rewrite this as negative 7 equals 2/3 x minus 5. It says h of x equals negative 7. Boom. Negative 7 goes there. Okay, and now let's solve. Plus 5 plus 5. Negative 2 equals 2/3 x, right? I'm going to multiply by the reciprocal because that's the way I like to do it. If you don't like the reciprocal, then do it in 2 steps. Multiply by 3, divide by 2. But I like the reciprocal because it's faster. 3 over 2, multiply by 3 over 2. Let's see what happens. 3 times 2 is 6, divided by 2 is 3, but negative 3, right? This is different than okay, before I move on, let's take a look at this. They're different. What does this say?
H times
So you put the negative 7 in. Does that make sense? This says the x, you plug in negative 7. You totally different answer. You guys agree with this? This says h of x is equal to negative 7. So I think the you see the difference between these two questions? Negative 7 is inside, isn't it? So you plug it in. Okay? Didn't say that. We're not plugging in it. We're going to set it equal to negative 7. Okay? That's a hard one to see. The difference between those two. Okay? Hopefully you see it. Okay? Last but not least. Okay? The graph shows the number of miles a helicopter is from its home base. Okay? So on a second flight, the helicopter flies a path of d of m, distance in miles, is 350 minus 125 m. Okay, which flight takes less time to get home? Okay, so here's the first flight. So the first flight, how long does the first flight get home? Hours home? Yeah, hours home equals 3. Everybody agree with that? That's, you can just look at the graph. Boom, 3 hours, he's home, right? Now, let me ask you an easy question. Easy question. When you're home, this is such a silly question, but listen carefully. When you're home, how far are you from home? Good. So that's how I'm going to solve this, right? I'm going to say the distance from home. So I'm going to take this equation and set it equal to 0. Okay, so I take flight 2. I'm going to go 0 equals 350 minus 125 m, because when you're home, your distance to home is 0. Okay? All right, now let's solve. Minus 350 minus 350. Negative 350 equals negative 125 m, right? Divide, divide. Need a calculator. Hold on, I got one right here. 350 divided by 125. Gotta get 2.8. Okay, so which one was faster? Obviously, the second flight, right? Second flight. Okay, what do you think? Not too bad today? Now, we don't have a lot of time for homework, but let's at least try and get started on it.